Terence Tao is one of the world's best mathematicians. He has won maths top prize, the Fields Medal, and many...
He looks older than 7.
would consider him a genius. His talents were recognized early, and he was a child math prodigy. He was dabbling in university courses when he was 9, and by 16 he had graduated from Flinders University in Adelaide. By 21 he had his PhD from Princeton. When Terence was 7, he was taking some math and physics classes at his local high school, and it was around this time that he was visited at home by Ken Clements, a researcher of mathematically gifted children. This report is Clements's thoughts and findings on Tao, including the results of a math test given to him, so let's take a look at it. It was the day before Terence's 8th birthday, the 16th of July 1983, exactly 38 years ago, and it says here that Terence was given an operations test. Knowing that he might find the first few questions too easy, Clements says, "You shouldn't laugh at the questions, because they get harder towards the end of the test." And Terence has an interesting reply. He says, "The questions won't know if I laugh at them, because they haven't got ears." He went on to score a 60 out of 60 on this test. On average, a Year 12 student taking the same test would be expected to get a score of only 53 out of 60. And here's one of those example questions. Question 58 asked, if P divided by Q divided by R is equal to delta divided by Q divided by R, then find delta. And here is 7-year-old Terence's answer. He writes it out as a fraction and then just does a bit of algebra to rearrange for delta, getting it to be P over R squared. Although it was clear to Clements that this test was too easy for Terence and they'd need to move on to some more difficult things. This next set of questions were presented to him and they had to be worked out mentally. They include things like, what angle does an hour hand describe in 20 minutes? Terence got all 8 of these questions correct as well, in a total time of 9 minutes. Clements noticed that while Terence had been solving the questions, he often justified an algebraic step by writing the appropriate algebraic law, for example, the associative law next to it. And so that prompted this following very interesting conversation. Clements asks, what is the associative law for addition of real numbers? Terence answers that it doesn't matter where you put the brackets. He also gives a correct definition of the commutative laws. And he also gives a correct definition of a group, something that most math students don't encounter until university. However, it seems that the first thing to stump him was being...
What is a group? A set which mapped onto itself by binary operation. The binary operation is associated in the set as an identity E, such as E times X equals X for all X in the set, also for each X in the set there is an inverse X.
Asked, what is a field? Terence replies, I don't know.
I don't know these.
Given that I barely
English,
have a grasp on what a field is now, I think it's forgivable for a 7-year-old Terence not to know that either. He does, however, know about the distributive law, and gives the example multiplication over addition. Clements asks if addition over multiplication is an example, but Terence replies, only for Boolean algebras. Clements was quite impressed by all of this. Not only did he have an astounding grasp of algebraic definitions for someone who was still 7 years old, but I was amazed at how he used sophisticated mathematical language freely. I was beginning to form the impression that Terence preferred to use analytic, non-visual methods in preference to making extensive use of visual imagery. Here's one of Terence's actual written solutions to a question that says, the length of each side of a square is increased by 3 meters. The area of the new square is 39 meters squared more than that of the original square. How long are the sides of the new square? Terence correctly finds that the length of the new square is 8 meters. The next set of questions given to Terence include, Suppose you decided to write down all the numbers from 1 to 99,999. How many times would you have to write the number 1? This one Terence actually gave an incorrect solution to, although still an answer that shows plenty of critical thought about the question. Apparently the correct solution here is 50,000. He struggled a little bit with a few more of these questions, and Clement says that at this stage Terence was showing slight signs of fatigue, although his interest was still high. So he asked him just 2 more relatively simple questions. First, he asked him to sketch the graph of y equals x squared plus x, which he did immediately. I asked him to find the coordinates of the turning point, and he wrote them down. This response took 20 seconds. I then asked him to sketch y is equal to x cubed minus 2x squared plus x, and in about 1 minute he produced this. It is interesting to note that Terence hadn't begun to study any calculus at school, but when Clements had arrived at the Tao household and was speaking with Terence's parents, Billy and Grace, he had spotted Terence sitting in the far corner of the room reading a book with the title Calculus. Terence's dad was a doctor, and Terence's mum was a graduate of physics and maths who had worked as a high school teacher. She said that Terence liked to read mathematics by himself and often spent 3 or 4 hours after school reading mathematics textbooks. Terence also had an interest in computer programming and had taught himself basic language by reading a book. And at the end of this first visit, Clements was shown one of Terence's programs. It was called Fibonacci and actually contains plenty of humour. Apparently, Terence wrote many of his programs when he was just 6 years old. So let's take a look at Fibonacci. It doesn't just calculate the sequence. It starts with, "Here comes Mr. Fibonacci. Can you guess which year was Mr. Fibonacci born? Write down a number, please." Then, if the user inputs the correct answer, they can start. However, if their guess is too far off, they'll be told, "No, he is already in heaven. Try again." Or they might be told, "Sorry, he wasn't born yet. Try again." Then, if they were close, it would print the difference between the guess
I do not
and the
fucking
actual
care
answer,
about these kids. I do
meaning
not
that
care
even
about
to
the
start-
other kids wasting money for attention. I do not care about a smart kid wasting his childhood just to cure cancer. Should these kids be out changing genders with all the other kids?
Okay, I'm gonna go ahead with no more link on that one.
At this program, the user is guided by a bit of mathematics. After printing some of the sequence, it ends with "Mr. Fibonacci is leaving now, and here goes his car." This line is perhaps the only reminder of just how young the author of this program is. 5 weeks later, Clements came back for a second visit, and he asked Terence if something was a field. Here was Terence's answer, clearly demonstrating that since the last visit, he now knew exactly what a field was. This kind of answer is something that a university student would be proud of, and it shows just how fast Terence was able to learn concepts. They encountered another thing, though, that he didn't know yet. He was asked for the antiderivative of 1 over x, and responded that he had not got up to that yet in his reading. But on a third visit, not long after the second, Terence had not only mastered the antiderivative of 1 over x, but was doing things like this with partial fractions. He was given a space visualization test, which again made Clements come to the conclusion that Terence preferred to use non-visual analytic methods, even if they required more complicated thinking than more visual methods. For example, with this question here, Terence said that he checked each shape by the reflection law, which was that each point had an image on the other side of the mediator, and he did not imagine each shape being folded along the dotted line. Included in the report was Terence's school timetable. The subjects marked with the asterisks took place at the primary school, whilst all the others took place at the high school. His teachers said that whilst 7-year-old Terence did have the academic ability of a 16-year-old, his maturity was still that of a 7-year-old. And Terence's parents had to balance giving him a childhood that challenged him intellectually, but also allowed him to fit in socially and emotionally. The report makes it clear that rather than being pushed along one rigid track of mathematical education, Terence was allowed to pursue the topics that interested and challenged him the most. He loved mathematics, and the efforts of those around him were to ensure that he did not become bored or frustrated with non-challenging work. Let's finish with a look at a program that now 8-year-old Terence Tao had submitted for publication to a student mathematics journal called Trigon. It is all about perfect numbers and is labelled here as Terence's first published paper.
Alright. Genius! I wonder how it did in the other grades.
If you liked the video, make sure to leave a like and a comment on what you want to see next.